Hola. Bienvenidos a mi canal. Esta es la tercera entrega de motores magnéticos con el principio de Perendev. Compilé todos los videos que pude encontrar del tema en 4 entregas. Algunos videos les retiré el audio original, por problemas de derechos de autor. Si quieres ver el video original, dejaré el enlace en la descripción. Quiero reunir toda la información sobre el tema, al cabo de unos meses haré un resumen en video de todo. Déjame todas tus preguntas, o nueva información en la caja de comentarios, al final intentaré contestarlas todas. Comencemos.
Now I'm calling this video how the Perendev motor worked, if it worked, because obviously Mike Brady, the inventor of the Perendev motor, is now in prison for embezzlement charges. Apparently he didn't deliver on the motors he promised. Now I'm starting this video out with a look at a design that I did a few years back for a mechanism I was going to have built to test the Perendev design and see if it actually worked. Now this came with pieces that could be removed and switched around, and that way you could try different formulations of magnets and test it in different ways and so on. Now part of the reason that I believe that the Perendev motor might have worked is that Mike Brady seems to have copied a patent that came out quite a few years before his motor did. And his design ended up being quite similar to what theirs was. Now this is a look at how the rotors were basically put together and how the design on them changed over time. Another point of interest, Sterling Allen on his PezWiki website recently released a lot of information that had previously been kept under wraps. And one of the things mentioned, everybody that's tried to put one of these together has failed, as far as I know. And I think one of the main reasons for that is the magnets that are in this, in my opinion, they have to be properly shielded. Every one of these magnets creates a field, and the north and the south field would become cluttered in this kind of configuration, and you'd get all kinds of flux loops. And I don't see any way that this rotor would spin without proper shielding. Now, supposedly, the way Mike Brady did it, he used bismuth, which is a diamagnetic material. In other words, it repels magnetic fields. The problem with that is it's a very light repulsion. It kind of sounds to me like something that he just threw out there to throw people off the trail so that they couldn't replicate what he was doing. Because that would not in any way shield these magnets through here. And you'd still have all of these flux loops because the material is just too weak to stop these fields. I think you'd have to use something like ferrite shielding. One of the reasons I believe that is, and this isn't a great copy of this, but this is the material that he was using for shielding. Now, if this were actually bismuth, it would be kind of a light whitish gray. This is a darker material, and it does not look like bismuth to me. It looks more like ferrite. You'll also notice there are these metal pieces on the sides here that supposedly were to keep the magnets from, tearing each other up from the forces of the opposing fields. I think this might have had an entirely different use right here. This is an overly simple example, but basically I think that those metal pieces were intended as ramps to help draw the magnets on the rotor and stator into the correct positioning. Now, to detail this a little better, this is how a standard magnetic field would work. The north being here, the south here, and the center point, of course, being the block wall where there is no magnetic field. By putting shielding around the magnet, what you would do is you'd block out the fields on the sides, redirecting them through ferrite or metal, and you would change the way the spins work, and they would be more tightly focused to the top portion where the magnet is still showing through. Now with metal shielding on the side here, as another magnet would come into close proximity, it would be attracted to this sleeve, and you're going at a 30-degree angle the way the Perendev motor appeared to do. Be attracted to the sleeve, and then when lined up properly with the opposing field, it would repel. Here's a brief rundown of how I think the rotors and stators are put together. Obviously there are 3 rotors and 3 stators in the original assembly. I believe the magnets in the stators and the rotors are 1 inch diameter by 1 inch in length. In the stators, I think they're spaced at about 1 inch apart, whereas in the rotors they're spaced about a half an inch apart. Now they have to be shielded in the rotor. I don't think you're going to get this thing to work without proper shielding. And I think you need these steel plates on here as well. Now, the way this pans out, we put all this together, the rotor and the stator, when you've got this offset pattern, at one point they should line up perfectly. Alright, the next set, and this is kind of tentatively called the golden ratio, the next set should line up at about the half point of the magnet, and the third set should be off here. So in other words, there's always going to be one magnet at 100% repulsion, one magnet at 50% repulsion, and the other magnet being drawn into the next magnetic field. So the full strength and the half strength here are greater than the strength of the field trying to repel the rotor from bouncing into this next pattern. In theory, giving it enough force to maintain rotation. Now here's another look at the idea of a golden ratio. And obviously this would work by offsetting the magnets that are on the rotor. Now to really put something like this together, you need to start with some type of flat track. It'll save you a lot of time and a lot of headache. This is one of the better ones I've looked at. It's designed by a gentleman named Mark O. The thing that I would do differently, this is intended to be a cart. I would offset these magnets at about a 1/4 inch apart and use this as the stator. And this piece at the top I would use as the cart, placing the magnets three rows of 3, 1 inch apart. The distance between these doesn't really make a lot of difference as long as you have a couple inches between each row. And you match them up with the cart, of course. It's interesting too, there's been a lot of discussion over how the magnets will be placed in the stators, and that's changed over time in different pictures you look at. with the Perendev motor. I think one of the main problems that Mike Brady might have been having with this thing, his first assembly was made out of aluminum, and supposedly that began to get magnetized over time, and it demagnetized the magnets. I really think by running this thing in repulsion mode, what it really did is it wore out the magnets. Because aluminum generally, what it does, it's only magnetized
when it touches magnets.
But it creates eddy currents. It would have slowed the motor down. I don't know that it would have deteriorated the strength of the magnets. And I think part of the reason he kept changing the design over time is he was trying to get past this problem of the magnets being demagnetized. And the main design flaw with his motor is that the stator magnets and the rotor magnets are always in repulsion mode. If you do that over time, you're going to wear out the magnets entirely. Eventually, the thing is probably just going to wind down. You have to find a way for the stators to attract and repel at the same time to keep the strength of the magnets intact without wearing them down. Which is actually more similar to what Howard Johnson did in his magnet motor patent, the rotating one that he had.
Now, this is a short video that somebody did attempting to put together a flat track to test out this golden ratio idea. And it works pretty well in the video. The only problem with it is it needs to be much longer to accurately test it. I don't think you can get a real feel for whether it's going to work in a longer rotating version with something this small. Now, this is a clip from a video that is an attempted replication of the Perendev motor that Sterling Allen put together. They never were able to get it to work, unfortunately. And I think one of the problems with it, because it's beautifully designed and they followed exactly what Mike Brady put together in his design schematics that he sent to them. I really believe it didn't work because the magnets are not properly shielded in the rotors. Instead of using something that would have canceled out the fields and prevented all the flux loops, they were advised to use something similar to bismuth that wasn't quite as strong. I believe it was graphite. And there's just no way using that you're going to get this thing to work. Now, I think if they took those shielding pieces out and replaced them with something better, they might get more favorable results out of that. Now, this is another video that is listed on Sterling Allen's website. This is a supposed partial replication of the Perendev design. And you notice he starts this out by hand, and then it appears to maintain a constant rotation here. It also appears that he has the magnets properly shielded, which is one of the most important parts. Now, the unfortunate thing about this, as is with many of these type of videos, is this is the only video that he appears to have put up and has not uploaded any since. So all you can really do is speculate as to whether this thing is really working or not, although it does appear to be.
Now, one of the few things in this assembly that you don't really have to question how it's put together are the rotors. The rotors are put together with this basic spacing. Each one of these has magnets that are about 1 inch in diameter by 1 inch in length. The first rotor at the bottom point of the first magnet will line up with the top point of the magnet on the next rotor, and so on to the third rotor here. Basically what it does is it forms a perfect line. As you see, it's almost like lining up one long magnet by doing it this way, the staggered effect. Then all you really have to concentrate on your stators is coming up with the correct combination to keep this thing constantly in a state of flux. I call this an imbalance system because it keeps the magnets from lining up in such a way that it can cog up and stop the device. Now you can get the exact measurements and stuff to build this from the PezWiki website. But the original arrangement had approximately 30 magnets on each of these rotors. Later designs had them at anywhere from 12 to 15. It was changing all the time, and they changed the way that the magnets were set up. There were spaces between each one. So, same configuration, just missing the magnets that would be here in the center points. I'm guessing that as Tom Brady changed the design, he did this as a way of trying to get past the problems he might have been having with the deterioration of the magnets by adding these spaces that might have helped. And also these are bored out at 30-degree angles, so obviously they don't come out straight at you. But I drew it this way just to make sense of the design. Now the distance between each of these different rotors, you don't want to get them too close together, because then you're going to run into flux problems with the magnets from rotor to rotor. It doesn't really hurt how far apart they are though. So that's really the only thing you have to take into account with that. Also, however many of these magnets you place on each of the rotors, you want to make sure that they are multiples of 3. Just because the skipping technique that is done in this type of design requires that. You need the 3 lined up in such a way that it would make it work. So you could do 30, you could do 15, you could do 12, whatever, as long as it is a variable of 3. It's very important.
The thing you'll notice from the construction of the track and cart is that the idea of the golden ratio that I previously outlined doesn't appear to work. So disregard my previous instructions on the magnets on the stators being 1 inch apart. If you follow the original blueprint shown on the PezWiki website, your results will be a bit more favorable. Though it's still a bit of a mystery how exactly the magnets on the stators are configured.
Okay, this is currently set up in a traction mode rather than repulsion mode. As you see, it pulls it partway into the track and then just stops. It's not by any means getting enough power to pull it through here. I've tried it now with it gapped through these places the way that they did on the later version of the Perendev motor, and with the gaps filled in. So next I'll flip this plate over here and try it in repulsion mode. And here it is in repulsion mode. It does try to kick it out of the front and does very little through the middle. You get to the end, it tries to kick it out. So in other words, for the folks that tried the smaller flat tracks, it probably look like it was actually doing something. When you build the flat track correctly, though, it just doesn't work. Clearly. Now, generally on a flat track, shielding is not as important as it would be on a rotating version of the motor. However, I threw some shielding down here just to demonstrate. I threw some neos on top of these and some neos on the track here just to show that it doesn't make any difference. Now it looks like it almost makes it all the way down the track. But if you remember, the proper way to test these is to place the cart in the middle and to see if it does anything. Which obviously it does not. So my only conclusion can be that this idea of the golden ratio is incorrect, or that the entire thing just doesn't work. So I'll try a different configuration for the cart and see if that makes a difference. Now, to redo the cart, what I did is I went back into the original blueprints and looked at these more closely. And what I noticed is that about every 4 pieces in the rotor, or 4 magnets, there are 5 in the stator that are offset, used for movement. So this obviously doesn't match a lot of the ideas that have been floating out there on the internet. I also have a copy of the original patent, which was filed but never accepted, probably because it's based on a former patent design that's already expired. Okay, so this is a bottom view of the cart with the new arrangement of magnets. Now, it does work better this way. Once you get into the close proximity of the track, it grabs it and shoots it right through until you run out of magnets to repel it. So it definitely works better when you go this way. But you can still stop it in the middle, and you get no motion out of it at all. So this tells me that it's probably closer to what it's supposed to be, but not quite there. There's some other things that I'll play around with on this and see what I come up with, and if anything comes out favorable, I'll post it later. But that'll mostly be it for now. I will explain why I did this particular setup the way that I did, though, in this video. The reason I did the staggered arrangement on the track here instead of on the cart is because that's one of the few constants with the pictures and the videos that we have of the Perendev. This specific arrangement really doesn't vary in the designs at all. So by setting them up this way, and they are angled, it's a lot easier to experiment around with how the magnets might have been put together in the stator assembly. Just doing that on the cart, so it's easy to flip them around, change the orientations and so on. Now the shielding really isn't necessary when you do this on a flat track, or not as necessary. I still have shielding on the bottom here, but you don't have to have the magnets encased in shielding because you're not arcing the geometry. If you did that, you'd have to have the entire magnets encased, except for the top portion showing here. Now, if you made this track probably 5 to 7 feet long, it'd be a lot easier to test this properly. But due to the amount of magnets that I have, I made the track a little bit shorter. And you get a pretty good idea of how it works here. Now, there really only are so many variables left because of the intensity that the Perendev motor was studied in videos and pictures that Tom Brady originally provided, and the information that Sterling Allen has provided more recently. The only real variables left are the types of shielding used, whether it was used on the rotor and stator assemblies or just on the rotor assemblies, whether it rotates by attraction or repulsion or perhaps a combination of both, and how the magnets were spaced on the stator assembly, which again is the reason that I've set up the cart the way that I have, so that you can experiment around with that. So anyway, by building a setup similar to this, if you go on Sterling Allen's website, you can download the exact specs of how the Perendev was originally pieced together. You should be able to build your own cart and track and experiment around with it until you get favorable enough results that you could actually test it out and find out if it really worked. At this point, I can't tell you one way or the other. I believe it's possible that it did, and partly because it's based on another patent design to begin with, and there are some similarities in the design to some things that I saw Howard Johnson do in the past. So the rest is up to you.
Gracias por ver mi video. En la descripción dejaré los enlaces a las otras entregas. Suscríbete para avisarte cuando subiré el resumen con toda la información que logre obtener. Chao.